Hello friends, this is a continuation of phases of compiler topic. In previous class we have discussed about the lexical analyzer. Okay, for that video you can see in the description, we will provide the link. Okay, you can see there. So after the lexical analyzer we have to move to the syntax analyzer. So what is a lexical analyzer will do? We know that before only it will generate the identifiers, means it generates the tokens. Okay, so what is a syntax analyzer? The second phase is syntax analyzer. What the syntax analyzer will do? The syntax analyzer, we can call it as a parsing, means the syntax analyzer will provide us the parse tree. We will first here the input stream or source program will enter into the lexical analyzer. The lexical analyzer will generate it will identify the tokens or identifier that all will convert into one format, that is in the tokens format. Then it will move to the syntax analyzer. Syntactical analyzer will generate the parse tree for the given input stream. So with the example you can understand easily, ma. So what is a example previously we have taken for the lexical analyzer, that only we will see here. So position equals to initial plus rate into 60. So what is the output for the lexical analyzer, ma? ID1 ID2 identifier 2 addition operator, ID3 multiplication operator 60. So this is the output for the lexical analyzer. Now we will see the output for the syntax analyzer. Okay, see, means syntax analyzer means parsing or parse tree. Okay, so see here, position, initial, rate and 60. So what are the identifier? 1, 2, 3 are the identifiers. Okay, so first equal to, then position is first identifier, so we will write as ID1. Okay, then what is the next one? Initial plus rate into 60. So addition operator, initial we can represent as ID comma 2, then multiplication, the multiplication in between the identifier 3 and 60. Okay, so the output of the syntax analyzer is, this is equal assignment operator. This all value will be stored in the identifier 1, that is position. Okay, by following the Bodemas rule, means multiplication having the highest priority by comparing the addition. Okay, brackets of division, multiplication, addition, subtraction. Okay, multiplication will be done fast, then it will move to the addition, then equal to. So equal to the left side one identifier means this total value will be stored in the identifier 1, that is position. Okay, it's correct? Yes, correct. Now what it will do? First it will multiply the rate and 60, means identifier 3 and 60. Then this value will be here. Then next means this total value will be, this total value will be comes here. Then identifier 3 added with this total addition. Then this total value will be stored in the identifier 1. See, understood, ma? Identifier 1 is a position. Multiplication, rate and 60 will be first multiplied. Then it is added to the initial, means identifier 2. Then this total value is assigned in the position. So the output of the syntax analyzer is the parse tree. See, I'll draw the figure clearly, ma. See, assignment operator, identifier 1 plus or multiplication, ma, plus id 2, then multiplication id 3, then 60. Okay, this is a outcome of the syntax analyzer. Now what is the third phase? What is the third phase in the phase of the compiler, ma? Third phase is semantic analyzer. Third phase is semantic analyzer. Now what is semantic analyzer means? What the semantic analyzer will do, it will check the syntax tree and the information in the symbol table to check the source program for the semantic consistence with the language definition. Means, for example, I am writing float c equals to int a plus char b. Okay, ma. For this, so if it will move to the lexical phase, what you will get the output equal to id 2 and addition operator, then id comma 3. Okay, it is lexically correct. What is the next phase? Syntax phase. What is the syntax phase output, ma? id 1 plus id 2. Syntactically also correct. Then actual, is this correct statement? Is this correct statement? No. Why? Because it's not possible. The combination of integer plus character will not be stored in the float. We have to change int to float, and this also should be changed to float. Then only the value will be float. The answer will be correct. So that will be checked by the semantic analyzer. Is it clear, ma? So the output of the lexical analyzer is the streams, means it generates the tokens. Then what is the syntax analyzer will do? It will generate the parse tree. Then what is the semantic analyzer will do? It will check whether the generated syntax tree correct with grammatically or not, or with the whether it is following syntax or not, it will check. Okay, ma. Means for example, a binary arithmetic operator may be applied either a pair of integers or pair of floating numbers, not the combination of both. Okay, clear? That will be checked by the semantic analyzer. So what we have taken the example previously, then you can understand easily, ma. So now they tell me what is the example. Position equals to initial plus rate into 60. Okay, so for that lexical analyzer output is, see, if you will write the multiple times, you will get the clarity, ma, how we are writing that. Okay, so next one. So consider it as a, the value is, this one is float, ma. This is integer, you know that already. Then is it correct? It is correct in syntactically, but it is wrong semantically. To make it correct, what we have to do? So you know how to draw the syntax tree. See here everyone, see here we have to change the integer value 60 to float. Okay, integer value to float. Then the answer is correct by using the semantically. Then see here, into 2 float of 60. This value 60. So integer. The value will be converted into float. The float in this one multiplied will get float value. Float plus this value added into float. Again this value will be stored in the identifier one, that is position. Clear? So the lexical analyzer will generate the tokens. Syntax analyzer will parse the tree, and semantic analyzer which is constructed syntax tree, that is correct or not it will check. Okay, thank you.